Ojje is a collection of attractive stories and audiobooks for kids, and a classic example of prompting and image generation. What we do for Ojje with AI: create or rewrite stories and audiobooks, whether standalone or in multi-volume adventures. Craft catchy titles with fascinating advertising summaries. Design enchanting covers with captivating titles. For ages 4 to 11, create multi-page narratives, generate vivid backgrounds and expressive characters, provide reading comprehension and vocabulary to help kids not just read, but improvise. Fascinating, isn't it? Wonder, how do we do it? We take user input and generate the underlying synopsis, which becomes foundation for story content, audio content, vocabularies, RC questions and answers, character descriptions, image descriptions. From these descriptions, we create prompts that generate incredible images and 3D characters with multiple expressions, ready for action. Our code runs on EC2 with data on MongoDB. FluxDev powers image generation with Dino and Clarity Upscaler deep learning models, while Claude 3.5 drives the story prompts. We use SQS to handle image prompt delays smoothly.
During the development phase of Ojje, we had some major problems. Let me highlight some major challenges and solutions for it. The first challenge we faced was during the process of image generation using Midjourney. During the development phase of Ojje, we had some. Since Midjourney does not offer an official API, we had to rely on a third-party service called ImagineGrow. Firstly, the time it took was more than 2 to 3 hours to generate 70 to 80 prompts, which was not good. On the top of that, we encountered a high number of failures during image generation. So what we did is, we introduced background tasks using Python's fast API to handle image generation requests asynchronously. Instead of directly waiting for each prompt to finish, we sent the prompt to SQS where they were processed in batches. To minimize the impact of failures, we added error handling mechanisms. If a task failed, it was retried or logged, ensuring that failures didn't cause complete downtime. This multi-threaded approach made use of concurrent execution to reduce overall time handling different images prompts simultaneously rather than sequentially. Later, we found that the customization options weren't available after a certain point for images. This made us to shift from Midjourney to Flux. FluxDev is one of the leading image generation models in the market. Client also was satisfied with the outputs generated by the Flux. However, despite the advantages, we encountered a few challenges with FluxDev as well. Occasionally, even with well-crafted prompts and hyperparameters, the images generated by FluxDev would come out blurry or of lower quality. To address this, we incorporated an upscaler into our pipeline. This allowed us to improve the resolution and quality of the images, ensuring that the final output met our standards regardless of the initial quality. Another challenge arose when FluxDev's API would either go down or when we exhausted our credits. The process was automated. Whenever the FluxDev API encountered an error or the credits are exhausted, the prompts were automatically sent to SQS. This way, tasks were queued for later processing. If needed, the user could manually trigger the API to retry image generation once the FluxDev service was back online or credits recharged. The next challenge was to automatically crop out the characters. In our project, we needed a reliable method to automatically crop characters from generated images. For this, we used Grounded Dino, a deep learning segmentation model. It worked well for isolating the characters, but there was a significant issue with background removal. Initially, we tried using various Python libraries like RemBG and background removal. However, the results were inconsistent. This significantly impacted the quality of the final images, especially when the backgrounds were complex. After testing multiple approaches, we eventually integrated ByRefNet, a specialized model for background removal. This model was much more effective in removing the background cleanly and allowed us to get the desired results. Let me show you some examples. It seems wow, right? These are some major problems that we faced during the development of Ojje.
At Ojje, we've transformed the content creation process, reduced production time from 70 days to just 2 days, ensuring faster delivery. Offer more content with even better quality, enriching experiences for young readers. Support a wider range of age groups. With enhanced image processing, our visuals are sharper, more engaging, and produced faster. And finally, we've made it cost-effective, moving from thousands of dollars per month to just few dollars per story, offering incredible value at a fraction of the cost. Thanks for listening to our tales.